Hi there. I'd like to welcome you back to the Northlight Photographic Workshops. I'm Bill Schwab and I'm coming to you from the Photostock studio here in beautiful northern Michigan. Today we're going to get to part 3 in our wet plate instructional series that I've been working on here. The last part that we did was collodion, and then before that was silver nitrate. Now you can see those links up here. The developer is a very important part of the process, obviously. It's how we develop our plates after we've coated them and sensitized them in silver nitrate, then put them into the camera, made the exposure. Then when we come back into the darkroom, we need to develop that plate. And so all developers in collodion, there's many different formulas that people use, some that are better for positives, some that are better for negatives. And a lot of people tend to have their own little mixture of developer. But basically they all consist of acetic acid, Everclear, which, as I told you before, is kind of the river that runs through everything in the collodion process, distilled water, and we also use ferrous sulfate. Now, ferrous sulfate is the basis of all of it. Now, ferrous sulfate, as you can see here, this is a very pure form of it that I get from a guy named Mike Jacobson at Artcraft in upstate New York, and I highly recommend this. And when I say pure, it mixes down very easily and it doesn't need any filtering afterward before you use it. Very often the ferrous sulfates that you get will be kind of, they'll have a little bit of other things in there, some dirt, and you never know what's in there. And it will add to some kind of cloudiness to the mixture. And you don't really want to use that because that can add to different problems like comets and other things that happen in wet plate photographs. And those are things that I'll get to further down in this series. But for now, you just want to have a nice, pure, clean developer, and this gives it to you right out of the chute. You know, I mean, you don't have to do any filtering or anything afterward. So, ferrous sulfate, alcohol, acetic acid, distilled water, and I like to use sugar, just plain white sugar, as a part of my formula. Now that sugar acts as a restrainer. Now developers can be quite hot with the acid and the alcohol, and hot that I mean that they activate and they act really quickly, and so you have to be really fast when you're doing your developing. I tend to like to work a little bit slower, and also as a beginner, I like to teach using a sugar or a restrained developer because it allows people to develop a little bit longer before what sets in is called fogging. And I have an example of that right here. You can see on this plate how it's gotten kind of fogged looking. It looks like there's a veil over it. Now there's other reasons that can happen, but most often it's in developer, and it's because of a hot developer, and it's because the development goes too long. You make an underexposure and then you try to push it a little faster in the developer, and it doesn't work so well because the developer can actually kind of start to burn the plate in a way and lead to fogging like you see right there. Now you want your plate to look nice and clean and nice and black like this, and that's achieved by a good exposure mixed with a good development. Again, the sugar, you can use it in various amounts, but I like to use it because it gives me a development time of, say, going from maybe a 7 to an 8 second development time. I can kind of safely push up into that 15, almost 20 second range using a restrainer like sugar in my developer. So the formula that I'm going to show you today is going to include this, and it's again a good beginner's formula. Other things that you're going to need are glassware, like I said in the other videos. You know, there'll be links below to this, but by now, if you've made it this far in the videos and you're actually performing the process, you've gotten yourself some different glassware. So you're going to need that, some graduated cylinders, small beaker, large beaker to mix in. I like to use glass stirring rods again. I'm going to need a spoon to mix out my ferrous sulfate, and I'm going to need a scale again to weigh that. And another thing I want is a final bottle. Now, I usually use these big brown bottles. This is my kind of favorite development bottle. I can find it easy in the dark and it's easy to pour. So anyway, I'll have links down to the place to get these as well. But you want that at the end to be able to put your mixed developer in. Now it's not a very difficult thing mixing the developer, but we're just going to do it. And it'll be fairly quick. Now what we're going to do is get into part 2 of this video, which will also be the fixer. And these will be the final kind of essential chemicals that you're going to need to do this process. Further on down the line, we'll get into varnishing plates, that kind of a thing, but I'm not going to confuse you with that right now. So anyway, with that, we'll do a second part to this video, and that second part will be the fixer. And I'll clear the table off and I'll bring out the new chemicals, which are going to be very easy. That one's sodium thiosulfate and water, basically. So there's nothing to it. That'll be quick. So with that, it's time to get on my safety glasses and gloves. And we can get down to the business of mixing up our developer. So the first thing that we should do, oh shit, didn't put on my glasses. Ha ha ha. Okay, so first thing we want to do here is turn on the scale, and we're going to want to zero out our scale before we mix up our ferrous sulfate. Now today what we're going to do is we're going to mix up 600 milliliters. Now I have the formula down below in a mixture for 300 milliliters and for 600 milliliters. It's best to go with 600, go with the larger formula at first because you're going to use it, and it's best to just have it around and not have to break up everything and go back and mix some new developer. Okay, so I'm here and I've got myself tared out and zeroed. So now I've got the ferrous sulfate here. Now this isn't a terribly dangerous chemical, but like all chemicals, it's best to use safety glasses and gloves. No reason to use a mask with this stuff. There's not really much of a smell, and if you do smell it, it smells kind of like a rust. Like it's ferrous, it's iron. Anyway, and it's a very nice powdery sugar thing. Don't let children find it because it looks like something you want to put on your ice cream cone or something. Anyway, so we're going to measure out here 30 grams of ferrous sulfate, and that's for the 600 milligram mixture. So I said 30 grams, yes, 30 grams, and we are right there now. Okay, so I set my spoon aside. I like to close up all of my chemicals before I move on to the next thing. And now, so we're all set with our measurement. We can set this off to the side, and what we're going to do is pour ourselves out 600 milliliters of distilled water. Now, I have a graduated beaker here. These I highly recommend. Make sure that they're correct, but this one's 600 milliliters, and I know this because I've used a nice graduated cylinder to measure it out and find out if the lines were correct. Anyway, so we're going to pour out 600 milliliters here of liquid, of distilled water. And we are there. Now, the next thing that we're going to need is our alcohol, and for this we're going to use 50 milliliters of alcohol. And I use my small beaker for that because it goes up to 50 nicely. There we are, right at 50. Set that down, recap. Always close up my chemistry, even if it is the Everclear. Okay. I'll add that into the water and give it a little bit of a twist, a little bit of a stir. Now what we're going to go with is with our acetic acid. Now acetic acid is like vinegar on steroids, and you can imagine what that smells like. When I open up this bottle, the smell of vinegar will be everywhere in here. You do not want to put your nose up to this. In fact, if you are allergic to smells, or if you have trouble with smells like this, just like the ether, it's probably best to get some sort of a respirator or a mask that helps you with organics and helps you with chemistry. You won't smell it inside of there, but it is kind of cumbersome to wear. Funny to talk about masks right now, right? Anyway, so the acetic acid, right away I can smell, and the acetic acid, I'm going to be using 20 milliliters of this. Now, I like to use as little of this as possible sometimes, but 20 milliliters is about the least I like to go with 600 milliliters. So there we are, 20 milliliters. Now, another thing I will tell you about chemistry is you never add water or other things to the acid. You always add the acid into the water, and it's a very small amount, and we're going to be doing that. And with acetic acid, it's a very benign one, but you're not going to want to keep your nose over it, keep your face over it. Always keep your face away when you're doing these kind of things. It's not going to erupt or do anything, but it's just good practice. So there we go. Now we have our acetic acid in there, and now I'm going to add in the ferrous sulfate. Now you'll be able to see everything will turn kind of like a pea green. but it dissolves very quickly, and that's what's really nice about this ferrous sulfate from Artcraft. Probably shouldn't tell you about it because you'll order it all and then I won't be able to get any more. Now, Mike's a great business. Now, I like Bostic and Sullivan, and I love, you know, everybody out there, all of the suppliers. If not for them, Chem Savers, all these people, I'll put links below. If not for them, we wouldn't be able to do all of this stuff. But Mike tends to work out good for me, not only in the fact that I like the ferrous sulfate, but just that he's fairly nearby and I can get UPS there overnight. Okay, so I've got it pretty much all into solution now. There's still a little bit at the bottom. And it looks a little bit cloudy right now just because there's a lot of air in there and it's bubbled up quite a bit. You'll see once I stop stirring, it'll clear pretty quickly. Anyway, I'm just going to let that go there while I mix up some sugar here. I'm going to bring my scale back in, and for sugar, I'm going to just use 30 grams of the sugar. I could even go less than that, but I'm going to use 30 grams. It tends to work fairly well for me with that. And the other thing about it is that if too little, it doesn't restrain quite enough. Now you can play with this again yourself. You know, once you become more adept at this process, like I say in the description of the one prior, once you become more adept with the process, you can start playing around with different formulas and find things that work for you. And then I highly advise you to stick with that. Once you found something that works for you, don't play around with different formulas all the time. I know so many collodion people and so many photographers in general that just like to play with the chemistry and the gadgetry to try different things, and that's all well and good. But for me, the end goal is the prints, and I want my work to be consistent and have a certain look that's identified with me, and that comes from consistency of workflow and consistency of all your chemistry. So eventually you're going to work up to the point where you have your own favorite formula, and you'll go away and you'll change your formula slightly different than this one. But anyway, with that, 30 grams of white sugar. I have a cheat sheet down here. That's why I keep looking down. All right, I'm going to tear out my scale, go to 0, and now we are going for 30 grams. We got 19. There we go, 30. Now, you can see that this is quite a large amount of sugar, and it breaks down, you know, as sugar does, real easily. And what it does is it just, like I say, it restrains or impedes the activity of the developer. I didn't go my own rule of covering up my chemistry beforehand, because sugar is chemistry. And there we go. We still have a little bit of sugar down in the bottom to develop, but as you can see, this is a nice clear formula. And all ready to go. I mean, if this was the ferrous sulfate that I have a big tub of in there that I bought 10 years ago and don't use anymore, this would be a cloudy mess, and I'd be filtering it for a little while or letting it sit overnight to let the sediment fall to the bottom and then decant it off. You can do that if you do use a different type of ferrous sulfate. Now also, I tend to like to use this. I mean, this is ready now, and I don't know why this is, but I tend to like to wait on it. So if, what I'll do is I'll mix up developer ahead of time and let it sit for overnight or sit for a few days and be ready to go. And the other thing about this stuff is it's ready for a long time. I mean, as long as you keep it in a good stoppered bottle, it's going to be ready for a long time. It does not go bad. So there you have it. There is our ferrous sulfate and acetic acid and alcohol, distilled water, and sugar. And don't drink it. Good looking stuff though. Okay, so now we're going to get down to the business of doing the fixer. So now it's time to get onto the fix, and as you can see, we've got a new chemical here on the table, and that is sodium thiosulfate. Now, sodium thiosulfate is the fixer that we're going to be mixing up today, and that I'm going to advise you to use in this process. Now, you'll probably heard, and there's other people have talked about the fact that you can use KCN or potassium cyanide as a fixer. And that's what's traditionally been used in the old times with the process, but it's very dangerous to use, and I'm not even going to talk about it. The thing about it is that you have to be very adept with chemicals before you use it, and even in those cases you can make mistakes. The thing about it is that using it, when it mixes with an acid, it creates a gas that will kill you. It's just plain and simple. It will kill you, and you have to be very careful using it. So with that said, stay away from it. Use sodium thiosulfate. It's cheap, plentiful, easy to get. And that's all I have to say about that. Now, sodium thiosulfate, I get mine from Artcraft again in upstate New York, Mike Jacobson. Great place. It comes kind of in a nice ground consistency. Pentahydrate sodium thiosulfate that you're going to want to use sometimes comes in little tiny crystals or little bigger crystals, and they dissolve a little slower. This stuff's really nice because it's ground down and it dissolves a little quicker. The way that I like to mix it is 100 grams of sodium thiosulfate to 500 milliliters of water. It's a pretty strong solution, and the fact of the matter is it does need replenishment fairly often. It exhausts fairly quickly. I tend to use it on one of these 8x10 plates. I tend to use I'll use one mixture of it for maybe 4 or 5 plates, and then I'll dump it and I'll go to a new one. The mixture of it is not terribly critical. Like I say, I use 100 milliliters to 500 milliliters of water, but you can be a little bit more, a tiny little bit less, but a little bit more won't hurt you. So with that said, I don't sit in the darkroom when I'm working out in the field and mix up a new batch of fix by sitting here with the beaker and a scale and everything. I kind of know what 100 grams looks like, and I kind of know what 500 milliliters of water looks like, so I just scoop some out of my bucket in the trailer and I pour it here into my jug, and I use it that way. And then I just shake it up, and it's very easy chemical to do. So anyway, with that said, you do have to wash a little bit longer than you would if you use KCN. Now some people say that that's an advantage of using potassium cyanide, that you use less water, that kind of thing, but I don't think it's a good enough argument to play around with your life, and so therefore, wash water, you have to wash a little bit longer. If you're doing an archival plate, one that you're selling to somebody and you want to last for a lifetime, you're going to want to wash that plate for 40 minutes, 45 minutes, something like that. But if you're just practicing and you're just learning this process and you're just pouring plates one after another like you should be if you're trying to learn this process, 10-minute wash is fine, and they're going to last the rest of your life. They might brown a little bit in the future, something like that, but they're going to be fine. Anyway, so let's get down to it. I'm going to measure out 500 milliliters of water here. Now, the water doesn't have to be distilled as in other parts of the process. It can be just tap water. That's fine. But you can use distilled. It's no biggie. And then I'm going to set up my scale here, and I'm going to measure out 100 grams, and we'll show you kind of what 100 grams of this stuff looks like. A lot of times it's, it's about, to me it's about the size of a big Dixie cup, and I like to just have one of those on hand in the bucket in the dark room, and in the dark I can just scoop it out, put it in the amount of water that I want, just shake it up and be ready to go. But for this demonstration, I'm going to show you what 100 grams of this stuff looks like. Now, it tends to be a little bit, I moved my spoon out of the way here. It tends to be a little bit light in volume, so we're going to be filling up this little tray to the brim. Right there where it's 60 grams, 85, 104, and I'm just going to leave it at that because, like I say, you can be a little more sloppy with this. Let me get my spoon out of here so I don't lose it. You can be a little more sloppy with this. It doesn't matter. It's not as critical as in the other chemistry. I wouldn't want to do this in any of the other chemicals that I use in this process, but with the fixer, it's fine. So then I just take it over to my beaker of water, and I dump it in and stir it up basically until it's clear. The little crystals take a little while to dissolve. If you're using warmer water, it goes a little quicker. And like I say, most times I just dump this into the jug and I'm ready to go. So it looks a little cloudy right now because I've stirred up a lot of air into there, but that will clear pretty quickly. Let's let that clear. And basically we're ready to go. Now, like I say, you have to wash a little bit more time with this, but that's not a problem at all. Just keep your plates clean, keep your process clean, keep everything consistent throughout this process, and you're going to do fine with it. It's definitely a process that likes consistency of workflow. So once you've worked your own method, you're going to be just fine with it. You're going to come up with your own formulas. You're going to come up with your own workflow. So we're ready to go. With that, I think I'm going to get down to pouring some plates. The next video, which will be linked up here when it comes time, is going to be on pouring a plate. Now, I'm not going to get fancy and go out into the field and do anything like that. We're just going to work around here, and I'm going to show you how you pour collodion onto a plate, and how you drain it off, and how you put it in the silver nitrate, and how you put it in the camera, and all that kind of thing. There'll be that next video, and then in the future, we're going to get onto varnishing plates, because all plates need to be sealed once they're done, and we're going to be using a traditional gum sandrak varnish. That again will be in a future episode. And if you're watching these sometime in the future, there'll be links in here to these others. Just keep looking for them for the wet plate process, 1, 2, 3 parts, that kind of thing. We'll eventually get on to the equipment also, the cameras that you can use. I have a fun thing that I do with Brownie cameras. I'll do a whole video on that one coming up. But for now, you're ready to go. These are all the essential chemicals that you need to perform this process. And so with the next video, we'll get with that. Now, I hope that you enjoyed this. If you did, maybe give me a thumbs up. If you haven't subscribed already, please do. If you know of somebody interested in this process, I'd really love it if you would spread the word, because the more people that know about this, the better. I'm trying to give you a step-by-step, easy method of getting into this process, which normally can be fairly difficult or fairly threatening to people. The reason I've done these is so you can see me working with the chemistry and that kind of thing. So with that, I really appreciate your time, and I hope you have a good time yourselves, and we'll see you later. Take care. Bye-bye.